G'day everyone, I'm Dr. Peter Price of Classroom Professor. Welcome to this week's video in the free math worksheet series. This time we're looking at the division algorithm, so the written process for working out division. So this is our example question today, 138 divided by 4. I'm using base 10 blocks because they do such a fantastic job of illustrating the process and revealing what's hidden and what this process actually involves. Let me just make a couple of comments before we start about the division algorithm itself. Of all the algorithms, this is the most complex. It has so many different parts to it, different types of processes. So when we're doing addition, we're basically just adding and then regrouping, and that's all we do. But in division, we do multiplication, we do subtraction, we do regrouping. There's an awful lot of thinking to do. There's division with remainders in almost every example. So it's by far the most complex operation that students have to do in terms of the written process. It's easily the one that more adults than other operations, more adults will say, this is one we should use a calculator for. And it's probably the one that adults reach for a calculator for most often in their everyday lives. However, let me say that doing division at this sort of level with these size numbers, so we're dividing by only a single digit number, and we're dividing numbers probably with 3, maybe 4 digits, is a very important foundation for students understanding numbers and being able to apply them in everyday life and ultimately do questions like this in their head. So we want students eventually to be able to glance on that and go, well, that's a bit more than 120. I know 120 is 4 times 30. So that they could estimate the answer. They'll basically be able to apply division in their everyday lives, providing they understand the operation process. And the purpose of doing this algorithm is not just to give them yet another routine to practice, but to illustrate to them what division actually involves in the base 10 system and give them something to basically hang their thinking on. So in times gone by, before calculators, everyone had to know how to do this mechanically with a paper and pencil as part of their job or their everyday lives because there was no other way to do it. Now that we have calculators and spreadsheets and computer software and apps and so on, most of us don't need to do division in this way. But we do need to understand division. And we do need to be able to recognize it when we see it in everyday life. We need to be able to use it quickly and mentally when we're shopping and that sort of thing. Okay, so with all of that said, let's focus on how to do this operation in a way that will help our students to understand it. So as I said before, it's not just a routine. There's a couple of problems with this algorithm. One is the language. The language that we typically use for doing this operation is not helpful for children, and I'll talk about what I mean by that in just a moment. Now, you'll notice here I've drawn up a frame with 4 sections. This represents the 4 that we're dividing by. The model that we're using is division by partition or sharing. So we know there are 4 parts to the answer. We just don't know how many go in the 4 parts. The other sort, of course, is quotition, and we would do that differently. But this is the way to do it with the base 10 material. All right. Next question is, do we do long division or short division? My view is that long division needs to be done at the start so students can see where it all comes from, especially with the base 10 blocks. And then when they get familiar with that, we can skip the lower steps and make it into short division. And then, of course, we can say there are other ways of working out division. We could explore those at another time. Okay, but for now, we're going to stick with the reasonably standard algorithm for division, starting with long division. So, here we go. We're dividing 138 by 4. And the first thing most people will say is, will 4 go into 1? I have to stop right there and say, that is unhelpful language. 4 doesn't go into 1. It doesn't go into 13 either. We'll get to that. That's the next step. It won't go into 1, so will it go into 13? 4 doesn't go into 13. 13 can be split up 4 ways. It can be shared among 4. It can be divided by 4. It can be divided into 4 groups, but we don't get 4 into 13. Now, I know it's an unusual statement. I learned it from my mentors learning how to teach mathematics, and I recognize that it's very, very good instruction. we should not say goes into. 4 doesn't go into anything. So I'll use different language. You're probably familiar with the goes into language. You probably teach it using that language. Most teachers do. But let me just suggest an alternative, which is about sharing. So we have 13 to share among 4. Now, we should go back. Here's our 100. Can we share this among 4 so that everybody gets 100? Obviously not. It's too big. We need to break it up. And we're going to break it up into 10. So let's do a swap. And we'll swap that 100 for 10 tens. Of course, children will have learned about regrouping in their number studies. They should be very, very familiar with what 100 is. And it's made up of 10 tens. I put them slightly out of place so we can see it's not just the group of, the single 100. So now we have more tens. Now we're going to share the tens. How many tens do we have all together? We have 13. You might put a line under the 13 to emphasize the point that it's 13. And we're sharing it 4 ways, or we're sharing it among 4. We could imagine these are 4 people, perhaps. How many will each one receive? Now, obviously, we could put 1 in each and just keep doing that until they're all used up. But clearly, when we do it in a written form, we want to be able to think about the answer. So 13 shared among 4. 4 times what can we take away from 13? 4 threes are 12, and that's the biggest one. So we're going to put the 3 here. This is in tens. 3 fours are 12. This is where we do the multiplying. So we reverse the division, if you like, and say, well, if we take away the 12, how many are left? There's 1 left. So we should be able to put 3 tens into each part of the mat. Now, this part down here, if you're going to do this with physical base 10 materials, I recommend you use some plastic containers that are the right size, something like Chinese takeaway meal containers, that sort of thing, if you have those. Anyway, so this is illustrating that part of the process. Everybody gets 3. 4 threes is how many children? Of course, it's 12. How many are left? We had 13 to start with. We've got 1 left. This one we can't just give to anybody because in division everybody has to receive the same amount. So again, we're going to do a swap or a trade. Put that 10 to one side and we'll put out another 10 once. 4, 6, 8, 10. How many ones are there altogether? Clearly there are going to be 18. We had 8 before. We've got another 10 to add to that. Now, this is where people say bring down the 8. And I used to say that as well, but it's not really about the symbol. It's not about moving the symbol. It's about how many ones do we have. So perhaps a better way of putting it, and I have struggled to come up with a better way, but the best one I can come up with is say write the 8 next to the 1 to show how many ones there are. There are 18 ones. Again, we're sharing among 4. We're not dividing 4 into 18. How many will each one receive? Let's use our number facts. What's the biggest multiple of 4 that we could take away? Of course, everybody gets 4. So let me do that quickly. These magnetic blocks are just wonderful, except when you drop them. There we go. Everybody gets 4. How many left? There must be 2 left because 18 isn't a multiple of 4. 16 is. So everybody gets 4. We write that up here. 4 ones. 4 fours are 16. Of course, there are 2 left. And there are different ways of writing the remainder. I usually write a lowercase r with a dot. You might write REM or a capital R or whatever. Okay. Now you can see from this arrangement down here that with the base 10 material, it illustrates the answer. You can see 34 in each space. You can see that that's the 138. You could conceivably push it all back together and regroup and make it back into 138. There's 2 left. By the way, we could take this process and say, let's check that we're right. Students aren't always going to want to do that, of course. But if we do this as an exercise, we can show them, here's 34, 4 times. How many will that be altogether? Well, 4 fours are 16. There's 16 ones, and we regroup 10 of those to make a 10. 3 fours are 12. There are 12 tens, plus another one is 136. We've got 2 left over here. If we add that 2 back on, we'll have 138, which, of course, is the number we started from. So to me, this is a good way of illustrating the algorithm. I love the way base 10 blocks show this so clearly. To me, this is the way to show division using some sort of base 10 material. let's just look very quickly at what is often called short division for this same question. Now, I would do the long division first so everybody can see all the steps and see where they come from. When students get used to it, they should be able to do parts of it in their head, and that's where short division comes into its own. So here we have 100 to share among 4. Can we do that? No. We've got 13 tens. Share among 4. How many will each person get? They'll get 3. And how many will that distribute, or how many do we share out? 3 4s are 12. We do this in our head. Take the 12 away from the 13. How many are left? 1 left. Put that next to the 8. We've now got 18 ones. Share 18 among 4. Everybody gets 4. 4 4s are 16. There are 2 left. There's the remainder. So exactly the same steps, but of course it's shorter and quicker. Now, looking at the looking at the worksheets themselves, you'll see that on the first couple of worksheets there are some plain number fact questions. So the number facts are arranged with this format so that students can make the connection and then they answer them. Then we have division with larger numbers with no regrouping. We move on to division with remainder, and so on. So there is a progression of questions, and the labels on the sheets themselves will help you. Down at the bottom we have some revision of all 4 operations in the number facts. So there's quite a lot to do. This is one of the longer videos in this series, but hopefully you will enjoy using the worksheets with your students, and they'll make real progress in understanding this operation. So that's it for this week, and I'll talk to you next time.